Good morning again, and thanks for being here. That's the monthly webinar. Previous webinars in March, in April, I tried to cover the telco edge, the network slicing as a service, and a couple of other stuff. So today maybe it's last day in May, so that's the May webinar. So before we start, let me just tell you I would say the general guidelines. We have the Q&A utility, so you can just post your question in the Q&A. I'll try after every section to have a look on the questions. If not, I have like a separate section at the end for the discussion and the questions. And if we couldn't cover that, I usually post the questions in like an offline post in LinkedIn, and I put the answers, and from there we can start a discussion. So today's topic is the orchestration in telco domain. You know, orchestration is a buzzword, so it is there everywhere in all domains, and it touched like many of our like daily work, people working on transport, on cloud, on OSS, on BSS, actually in everything. You always hear the word orchestration, and because it is there in all domains, there is like a common I would say confusion or uncertainty about the term surrounding the technology itself. So let me just start with a quick introduction to myself for those who first time to attend the webinar with me. My name is Karim Rabia. I'm currently the ICT chief architect of one of the, I would say, globally leading technology vendors, okay, NEC. And my background actually spans from like mobility domain to cloud to orchestration to OSS. So I had different roles on different companies. You can see that. And also in addition to that, I have some, I'd say, community contribution, being part of some of the standardization organization and open source working groups like ETNFV, OpenNFV, and also ITU, and several other communities. So I usually follow a classic approach. Classic means that whatever content I bring, I always try to have a reference for it. So I try to minimize the generic terms. I always try to bring content that have a reference, and if it is my point of view and or my vision, I would say highlight that explicitly. So I hope you'll enjoy this webinar, and I think we can start with the agenda. So today's agenda, we have 6 main sections. Let me use the pen here. So before we go into like the orchestration concept and bricks, I prefer that we start to understand the enterprise structure, how any enterprise, including the CSPs and the telco providers, how their domains are structured, because it is very important to understand how the orchestration solutions are positioned within the organization, I say on the technical level, on the organization level, because that's a very common doubt that I always meet with my customers. So that's the first and 2 sections. So first and 2 sections, we can call them the foundation or the build-up for the webinar today. And in module 3, I go with I'd say, explaining the concept of the orchestration. What are the main bricks that construct any kind of orchestration solution? And then I hope by module 4, we can start to map whatever we had in module 1 and 2 and 3 in module 4, which is actually a few examples I brought from the telco domain, touching several domains. And we'll try to map whatever we had in the first 3 modules to module 4. And then I talk in the module 5, what's happening on the ground, what are the real challenges on adopting like an end-to-end orchestration solution, providing the promised agility and this kind of promises that any kind of orchestration can bring. And then it takes it's a discussion on the Q&A. So let's start. Let me make sure that I am recording. Yeah. Okay. So the first section, understanding the enterprise anatomy. And when I say here enterprise, it's a generic term, but in the context of the webinar, enterprise is actually the ISP or the CSP or the DSP, the one that we are assessing which actually maps to the telco enterprise. So I'm starting from the information framework domain, or the SID, Shared Information and Data Model. That's actually coming from TMF, TM Forum. And it's simply giving some sort of a reference model and a common vocabulary and common understanding for actually some sort of domains building up the organization or building up the enterprise that we are now focusing on. So this reference model suggests, and by the way, it is followed by all the operators, that any kind of enterprise consists of 7 domains. Okay, we have the enterprise domain, partner domain, resources domain, service domain, customer domain, product domain, and market sales domain. I would say that any one of us, either he knows or he doesn't know, or any one of us, actually works on one of these domains, one or several of these domains, or few of these domains. So just quickly, the enterprise domain, that's actually the internal domain of the enterprise. You can map that, for example, to HR, to finance, to whatever enterprise process happening there. Partner domain is actually, that's where you interact with third-party companies, like doing, for example, technician dispatches, doing some sort of workforce management, like interacting with third-party resources. And then resources domain, that's actually the resources part. You can easily map that to, for example, the cloud domain, which is resources domain, the virtualization, the transport, the network. These are all resources. And then the service domain, that's the domain where it governs the service. You can think of any kind of service, like voice servers, voice over LTE, voice over Wi-Fi, any kind of VASs that's there in the service. You can think also of maybe the core guys, the packet core, for example, as a service. And then customer domain, product domain, and that's where you start to see the interlock between the network and the IT. So some enterprises using this framework to drive the borders between network and IT. So customer domain, where you see terms like customer order management, handling customer tickets, CSR, like the one used by the customer representatives doing support for the customers. And then product domain, that's where you define your commercial products, your commercial bundles. That's purely, I would say, BSS IT part. And then the market sales domain, that's where you find the marketplaces, the e-channels, the way the CSP doing, like sells his products, the shops, okay, the interface for people working on the shops. So these are the domains. And from TMF, we talked about the horizontal domains. So there's always also a context for what we call an end-to-end vertical processes. So across the enterprise, there are some vertical processes that spans across all these domains. And when you start now to interpret the terms, I'm sure that most of us will be familiar with these terms, or some of these terms. We have the strategy, infrastructure, and product, SIP. We have the operation, support, and readiness. We have the fulfillment. I know that fulfillment is a very trending term in any CSP. And we have the assurance, and who doesn't know the assurance, like the fault management, performance management, service quality management. And we have the billing and revenue management. So these are the end-to-end vertical processes that spans across the domains. Actually, the intersection of these domains with the processes delivers something that we call the TAM, the Telecom Application Map. So the Telecom Application Map is simply, and I just selected some applications. If you see here, I just now focusing on the product, customer service, and resources domain. I excluded the enterprise domain and the partner domain. And if you see the intersection of these domains with the processes, you find there is now some sort of applications is appearing now. These are the what we call the level 1 applications or the telecom applications. Why we do like such architecture? Because this is actually providing us with a common framework that can CSPs and vendors share, that can CSPs build their RFPs based on, help them to procure these applications, for example, confidently, regardless of what is that. A CSP can go and then ask in an RFP for a vendor to deploy a SIM, a customer information management. And then in the TMF, you will see this a kind of requirements of SIM. It can be shared by vendors, and each vendor map that to its own product. Before I go further, I just give an overview of what I said till now, that from a TMF, the information framework provide a reference model, okay, for a structure of an enterprise based on domains. We have 7 domains, and we have vertical processes that span across all these domains. And some sort of, we can call it an intersection of these processes with the domains. It outputs some sort of telecom applications. These telecom applications actually can be mapped to vendor products, and even can be mapped to technical teams. So you can form your teams based on that. You can use this kind of framework to do some sort of borders between BSS, OSS, IT, and network. So it's a very nice and handy reference. I will just read some of these application names. Okay. So for example, in the product domain, I will not explain the application, but I'll try with you to interpret what does the term mean, okay? So there's something called product catalog. So it looks like that's some sort of index or a catalog, okay, that include all the CSP's commercial products or commercial bundles, okay? And that's why it makes sense that you find that in the process of strategy and infrastructure and products. So that's where you design your products. And then on the OSR, or the operation support and readiness, people working on OSS and BSS, when they heard the term OSR, that always maps to inventory, okay? So operation support and readiness, if you see in the customer domain, that's a customer information management. So it looks like that's where you keep the information of all your customers and what are the services that they are purchasing. And there's something called service inventory. So there's inventory. It seems that that's the inventory. That's the file that include all your allocated or leased services. If you go to fulfillment, and fulfillment is actually to deliver a certain order, you have the customer order management. And the customer order management, which is commonly known by COM, is a very well-known product or capability on the BSS. That's a very well-known thing, responsible of fulfilling the customer orders resulted from a certain purchase from the sales domain. So when a customer goes to a digital marketplace of the CSP or an application and requests a service, it goes to the COM, okay? And as you see, in the assurance, there's a customer problem management, so that's taking care of the customer tickets. And for sure, on the billing and revenue, there's the bill calculation. But you see, sometimes there are some capabilities that span across multiple processes, something like the CSR. CSR toolbox, this is actually the handy tool of the customer representative that communicate with the end user. So he must have access to the customer problem management, to the bill calculation, to the customer order management. What I'm saying that because I like always to have a reference, and I encourage all professionals working on the telecom domain to understand the telecom application map, and again map whatever they are doing to the telecom application map. So let me take some questions, and we'll now together we'll try to see where are the orchestration spots in the telecom application map. I'll take some questions. The questions, what is level 1 application? So when you start to see the TAM, there are some breakdown of applications like level 1 and level 2. And I'll explain that in the next slides. So there's some sort of hierarchical of the application. So for example, service order management is a level 1 application. If you go under service order management, that will be a level 2. So in the questions, Is it going to be recorded? Yes, it's going to be recorded, and I will send you the slides. Which domain is responsible for managing network equipment? We will cover that. Telecom map are defined under any specs or standard. Yes, telecom maps is part of the TMF frameworks specifications. It is available on the TMF website. There is also interconnection between domain and process, how it is mapped in TAM. I'll explain that. Security mechanism used in orchestration system. I'll explain that. CSMF, NSMF. I'll explain that. So okay. Let me just proceed. I will group all these questions in the last section if we have time, as we agreed. So we explained on a high level the enterprise anatomy, the concept of domains, the concept of processes, and the concept of telecom applications. So where is the orchestration? Okay. So the first spot, okay. Customer order management, service order management, resource order management. This application is level 1 application. If you dig in this application and you go to level 2, you see a service orchestration capability. So that's why usually teams or departments working on different domains, if there is no real good sense of enterprise architecture, they will always have a confrontation when it comes to orchestration, because each one believe that he should own the orchestration. But actually, the orchestration is not a generic term, right? Orchestration is there per domain. So in a customer domain, there is an orchestration capability in the COM. In the service domain, there is an orchestration capability in the SOM, service order management. And in the resources domain, there is an orchestration capability in the resource order management. And I'm bringing here the breakdown so that you can have really a clue about it. So service order management, from standards perspective, and even people working on the SOM level, and usually SOM is actually the interaction between the BSS or the IT and the network, according to how you name that in your environment. But under service order management, there is a concept of service order orchestration. So there's an orchestration on the service order. So actually, what is a service order? Imagine that from a customer domain, a certain customer purchased a certain service that actually consists of, for example, he purchased an SD-WAN service. So he is having like a new branch, and he's onboarding like a new security firewall. So a mix of two things, right? A new branch, and let me just see the chat. Okay, so like is a new branch and a new VAS, value-added service, a new firewall. So this kind of order or request will come to the SOM from the customer order management. And the service order orchestration perspective, he must know that this order must be decomposed into two services. One will go to bring up the new branch, and one will go to bring up the new VNF. For sure, it's a very informative example. We will have a section for the orchestration flows, so don't worry about that. I'm just building up, as I said. So if you go to SOM, you find that there is a concept of service order orchestration responsible of two things: service order decomposition to the underlying domain, to the resources domain, and service order tracking and management to make sure that the service order is fulfilled. For example, the branch is fulfilled first, and then you do the VAS. And once you do that, you go and update the inventory. So this kind of brain, okay, is there in the orchestration under the SOM. So it is there in service layer, it is there in the customer domain, it is there in the resources domain. So people starting to fight about where to position the orchestrator and who owns it should have seen the big picture coming out of TAM or TMF as a reference. And as I said, enterprise architecture, they have really an essential role in that. The other spot for the orchestration is actually, you can find the orchestration as some sort of horizontal capability that spans across multiple processes in a certain domain. And what does that mean? And why is that more, I would say, practical approach to map to a product, to commercial products, because you can have an orchestrator that have some sort of horizontal capability that include an inventory, that includes the function of a sum, and includes also an assurance capabilities. And that's actually, if you see any orchestration in the market, you will find these ingredients in that. So an orchestrator can be a horizontal capability that group multiple applications from multiple processes. And again, that's the case in many orchestrators in the market. It is there in the service. Also, you will see that it is there in the resources. So as a takeaway for the orchestration positioning, and that's the last slide before we explain the orchestration bricks, that one, orchestration exists in multiple domains. You have to know that. There can be an orchestration in the resources domain, like the ETNFVO, and I will explain that. It can be there in a services domain, like service orchestrator, domain orchestrator, okay? It can be there in the customer domain, or in the IT, or in the BSS, part of the COM. So we have to flexibly acknowledging that. Orchestration can be part of an application, like it can be embedded in a SOM or a COM. It doesn't have to be a product like an orchestration product. It can be there in the SOM because of the decomposition capability and service tracking. So that's a function also of an orchestrator. Orchestration can be a capability that spans across multiple processes. And I'm telling you, the majority of the orchestrators in the market, they are thinking of the same mentality. Any kind of orchestrator in the market, you will find a catalog. So that's coming from the strategy process. You will find an inventory coming from the OSR. You will find an order management coming from the fulfillment. And you will find also some assurance capabilities coming from the assurance. That's why some people like to say that orchestration on the service level is a next generation OSS. I don't acknowledge the term because there is no definition for that, but they see that that's the future of the OSS, like a new wave for OSS to have all these like legacy OSS applications or legacy OSS systems as part of one orchestrator, horizontal orchestrator. And the last thing, and that's interesting, we said that orchestration exists in multiple domains and they span across multiple processes, but also some market solutions, they provide orchestration solutions that span across multiple domains. For example, you can find one orchestrator taking care of the resources domain, also having capability on the service domain. And that's very common in some of the market solutions. We can have a look on that if you have time. But from a community perspective, open source MANO, for example, OSM, and I will explain that, it has both capabilities. So it can take care of the resources, like resources orchestration, integrate with OpenStack, integrate with Kubernetes, integrate with AWS as a normal orchestrator. And then also it can provision services like slicing, like end-to-end real service. Okay. So that's the main takeaways, and this is the foundation that I needed to explain before we explain the bricks of the orchestration. So let me just stop here and I pick questions. I would like to know the relation between OSS and NFVO orchestration. So OSS has always been defined as a northbound of the NFVO. So OSS from HCNFV perspective, it's a generic term that refers to the northbound of the NFVO, and I explained that in the few slides. How do we pick RFP requirements from the ETOM? That's a very good question, because actually ETOM and TAM, one of the main goals of these documents is to provide a guide for procurement. So it is there. If you go to the documentation, you will find that there is like each application, the requirements are explained. So the easiest way, for sure, you take the requirements and you put it to the vendors, enhanced by your custom requirements. How orchestration different from the traditional OSS BSS? I showed you that if you have an orchestration capability that spans across all these vertical processes, That can be seen as a modernization for the OSS. In addition to that, to the fact that the modern orchestrations are all cloud native based on microservices. So that's how you see that as a next generation OSS. I don't think it is impacting the BSS, because BSS is a little bit different, but at least for sure there is a disruptive momentum in the OSS. Orchestration and controller is the same thing. I don't believe it is the same thing, and I will show you the difference or the analogy between orchestration and controller in one of the slides when I talk about the MEF architecture. So really, I have a huge question, so I do promise that I will group all these questions and have it covered offline, inshallah. So let's now get back to the slides, and please, I would say module 3, that's the core part of the webinar today. So let's focus again. So orchestration main bricks. What I'm going to explain now actually exists in all orchestration solutions in a way or another, whether it is commercial or it's a community or open source initiative. And these are the foundation that any orchestration rely on. Let me start with what we call a design time environment. And you will always see in the orchestration domain, there is something called design time environment and runtime environment. The design time environment, where you do the modeling for the service, where you do the testing, certification, whatever. And the runtime, that's actually where the magic happens. That's the orchestration brain. It might look a little bit a basic definition, but that's the case if you review the own app. And we will go to the own app slide, for example. I will map this a term or understanding to the own app slide. So what's happening on the design time environment? You see terms like modeling, testing, certification, and CI/CD, and many other things. So I'll start with the modeling. Okay. To do an orchestration for certain service, regardless if this service is a resources one or a real service, you need to do a modeling for some sort of descriptor, a service descriptor that actually shows how is this service structured, what is the structure of the service, what are the components of the service, how do you build the service, like for example, you go and instantiate X and then scale Y, or what is the flow, the exact flow, what are the policies linked with the service, for example, how do you scale, how do you heal. So actually, imagine that you are doing one slide explaining a service. It is the same, but in a modeling language. Like you do the modeling of the language that any kind of orchestrator engine can understand the model. And whenever he gets a request from an external system to trigger this service or instantiate this service, he can just take a look to this service model and understand exactly what he needs to do. So that's a design time. It's usually linked with a staging environment or a lab environment, so that you can do the testing. What is the testing? That whenever you do the modeling, you do a testing instantiation or a testing invoking of this service, and then you do some sort of certification. For example, if the service is to run on Red Hat or Mirantis or Canonical or Kubernetes or whatever, so you do the whole set of modeling and certification and testing on staging, and then you go to the live sites or the commercial sites. So any kind of modern orchestration have this kind of design time environment, and vendors compete in the digital experience of such tools, how to give a nice experience for developers and the customers' teams. And then you have a very important brick, which is the runtime catalog. And please always keep in mind what I've shown you in the tab, where you see the catalogs. And catalogs exist in product and in service and the resources domain. So in the catalog, actually, the output of the design time environment, the modeled service, the templates, the packages are all imported in the catalog. So catalog will have the descriptors that describe the service or describe the VNFs. For example, in NFV domain, we have the NS network service VNF descriptor based on Tosca or Yang. Tosca is the most adopted. We have the CSAR packages, like the packaging of the VNF or the packaging of the network services. we have the service decomposition. Like for example, a definition that this service, to fulfill service X, you have to decompose the service to instantiate Y and Z and A, B, and C. So that's how the service is decomposed into, I would say, sub-services or VNFs. So this kind of decomposition, it is there in the catalog, and it is a result of the modeling done on the design time environment. You have the workflow composition, and the term workflow is a very, I would say, term that is coupled always with the orchestration. So workflow is important because it draws a certain workflow logic that orchestrator have to follow to instantiate the service, for example. For example, if the service is composed of a VNF A and B, the workflow mandates that you instantiate A, then B. You cannot instantiate B, then A. And if the service gets more complicated, the workflow gets more complicated. And in the workflow composition, you also get a rollback scenario. What if scenario? Like what if you get an error, how do you roll back? So all these logics are defined in the catalogs as part of the service descriptor or the VNF descriptor. You have the LCM policies, lifecycle management policies. When do I scale? For example, if CPU reach 80%, or if the attached success rate drop to 70, all these logics are there as part of the policies. It is there in the catalog. Monitoring artifact. What do I need to monitor for sake of lifecycle management? And that statement is important. Why? Because any function can output thousands of metrics. And these thousands of metrics are usually collected by EMS and then sent to the OSS systems for FM and PM. But for sake of lifecycle management, the orchestration commonly monitor a subset of these functions. So what are these metrics that need to be monitored by the orchestrator? These are all defined in the catalog, or the descriptor that is there in the catalog. Scripts and configuration, like what we call D0, D1 configurations, are all there in the catalog. And many other things there in the catalog. Actually at the heart of the orchestrator, and it's a very big dependency between the orchestrator engine and the catalog. Catalog can be external, nothing prevent conceptually to doing that, but usually it is there in one orchestration solution. And then there's a main brick, which I called it the closed control loop. The closed control loop usually have three things: the orchestration engine, the monitoring utility, and the policy engine. Okay, so what is closed control loop? Usually as an orchestrator, you do something, you execute something. For example, you instantiate a VNF, a CNF, you instantiate a service, and then you do monitoring for the artifacts defined on the catalog. And when you see a certain trigger or a certain input, you detect a need to do another action, for example, to scale, to heal. So that's the closed control loop. And that's a typical requirement from any orchestrator, to have the capability to do closed control loop. So the what to monitor, it is there in the catalog. What is the action to do upon monitoring? It is there in the catalog, it is there in the template. And the policies are statically defined also in the template. It can be more advanced if the policy is not statically defined, but it can be an output of a certain machine learning model or machine learning solution that is implemented to have these policies dynamically defined. And then the last brick, and the main, also one of the important bricks of the orchestration, which is the active inventory. So whenever orchestrator fulfills something, like I am an orchestrator, I managed to instantiate a service, I have to update the inventory that now this service is up and running. That's why in the inventory, in any layer, in any orchestration, in any domain, you can see the list of all service instances instantiated, list of VNF records instantiated, the full NFVI inventory, like what are the data center utilization, data center capacity, that's how many of them, or the percentage utilized and the percentage free, and any kind of inventory according to the domain, you will find in the active inventory. So from now on, I hope this slide is clear. Whenever you assess any orchestration, search on these four main bricks. I'm sure you will find them. Okay, and I will show you that. And if you remember, that was the intent. that we take this slide and we take the previous understanding, and then we go to the examples in the telco market, and then we try to map these blocks to the telco orchestration solutions. So I can stop here and then take some questions. Could you show us, please, orchestration in 5G network? I will do that. There is one slide. The eSign design, the eSign time tool isn't a cross-compiler tool chain. The design time tool or the design time environment is a generic term that actually refers to all set of tools that doing CI/CD, CT tools. Okay, so it can be anything. How ESB, enterprise service bus, I guess, is different from the orchestration SOM-COM ROM. So that is a very I would say, yeah, not a generic question. Okay, let me. Okay, I explained that there is an orchestration sense in the COM and SOM and ROM. Okay, and it's up to the enterprise architecture to decide whether the new product that you want to purchase as a team or whatever belongs to which layer, and it can even map to a layer that does not cover the SOM and COM and ROM. Okay, and for example, if you see the NFVO, the NFVO has a capability, okay, that covers the function of the ROM, but the NFVO, for example, does not go to a service level, and I will show you that in a while. So to answer a question how a product is different from a product, actually I cannot tell, and no one can tell. Okay, only the enterprise architecture, okay, judging the overall architecture mapped to the vendors, because they always listen to the vendor solution. They are the ones who can define. I mean, you have to have many inputs to define the borders between solutions. Okay. When Tosca heat do perform some function in what? Okay, so the question about Tosca and heat. What scenario closed loop work? Okay. So I will explain the difference between Tosca and heat in the HCNFV MANO slide. And there is one question: in what scenario closed loop work post instantiation of VNF and CNF? I will explain that in the orchestration flow slide when I talk about the scaling use case. Okay, so let's now move on. Till now, I hope that the content is not, I would say, what is the right term? It's not a heavy one. Okay, I just tried to give like a foundation before we move forward, and we may have more focused session. But I hope till now the concept of orchestration and the main bricks are clear before we go to the examples. Okay, so we will try to map whatever we have explained now to some real examples in the telecom domain. I start with the HC MANO. So that's the well-known reference architecture of HC NFV, network functions virtualization. And the MANO itself stands for management and orchestration. So all these kind of brains and controllers are grouped under the name MANO. So MANO has the VIM, the infrastructure management, the VNFM, VNF manager, and the NFVO. So the VIM is typically for example, something like VMware, like OpenStack. And in draft versions for HCNFV, it can be Kubernetes as well. And the VNFM is a functional block that takes care of the lifecycle management of the VNF. And I will show that, well, this is not a webinar of HCNFV, but I will show that in the orchestration flows. And then we have the NFVO. So guys, please now start with me to think. I told you about the main bricks of the orchestration. So now when I tell you about the repositories that's included in the NFVO, maybe now it starts to, I would say, to make more sense. So in the NFVO, we have the NS catalog. So yes, we have a catalog that includes all the network services modeled in that NFVO. We have the VNF catalog. So we have a catalog of all VNFs that are to be onboarded. And we have the NFV instances. Like if you instantiate a VNF, you will see it here as a VNF record. If you instantiate a network service, you will see it here as an NFV instance. And you have the NFVI resources. Like, for example, if the NFVO manage 10 DCs, then each DC, you will know from the NFVO that each DC includes, for example, 15 server with number of CPUs, how many of them are utilized and how many of them are available for new services. So that actually match the catalogs, that actually match the inventory that I talked about. And inside the NFVO, you have the closed loop control, and you have the also any kind of NFVO or a solution. You can have also the design time environment. And NFVO have a northbound interface with a generic block called OSS BSS. This maps to any northbound of the NFVO, and that northbound can be even an orchestrator, but in another domain. It can be a service orchestrator. So if you ask me now, NFVO, is it an orchestration in the resources domain or service domain or customer domain? Then I'll tell you confidently, NFVO from standards perspective, it is an orchestrator in the resources domain. It takes care of the cloud resources, of the VNFs on the cloud. However, it doesn't take care of the service. Let me give you one clear example. If you are hosting a VNF, an IMS VNF that is actually participating in a voice over LTE or voice over Wi-Fi service, if the VNF is misbehaving on the CPU level or a virtualization level, that's the responsibility of the NFVO to scale or heal. But what if the quality of the service as a voice over Wi-Fi has been degraded? For example, the success ratio of the calls, or maybe the voice clarity of the call itself. This is out of scope of the NFVO because it doesn't see the real service. Okay, so taking that concept and going to a poster that sometimes we used to have it as a reference, which is Zero Touch Orchestration, Operation and Management, Zoom by TMF. You see that they have the NFVO here in the resources orchestration layer or the resources layer, and the end-to-end service management and orchestration or the end-to-end SO in the service orchestration layer. So you see here the interlocks. And if you see the bricks inside the NFVO, I'm sorry, it is tiny. There is something called network service orchestration. That's the network service orchestration inside the resources domain. There's a big difference in terms between network service and service. Network service from NFV perspectives are like chain of VNFs connected together. They don't care a lot about the service they are carrying. But service orchestration, it's actually orchestration of the service they carry. And that shows the borders between a cloud team and service team. Cloud team makes sure that these VNFs are in good shape, interconnected, following the modeling, the template. But service team or the VNF owners are responsible of the real service that these VNFs are carrying. Inside the NFVO, there is a network service orchestration, a resource orchestration for the cloud resources, and a closed control loop. This means that they have some capabilities to monitor the VNF's network service and to detect there is a trigger to do an action to heal or to scale. Another example from the community, which is the ZSM, Zero Touch Management and Service Management. And why did I bring this one? Because people always ask me about the concept of domain orchestration and having multiple domains and having one multi-domain orchestration on top of that. ZSM is bringing that concept and advocating it. So you have like multiple management domains. This domain can be anything, can be transport, radio, core, whatever. And each domain, it has its own domain logic, like domain orchestration, domain control, domain assurance, everything within the domain. And all these domains are interconnected with something called end-to-end service management domain, which is sometimes referred to end-to-end SO, being a multi-domain orchestration. For example, if a certain service span across two different domains, then the end-to-end SO will be responsible to talk to these two domains. Okay, but within one domain, The domain orchestrator within that domain is the one responsible to do the service lifecycle management within the domain. And that's very close to the concept of NAS, network as a service. Like you are transferring all your network into administrative domains that actually expose service to northbound system that can consume all these APIs from different domains and construct an end-to-end service or end-to-end product to the consumer or the enterprise. So that ZSM, it's part of ITSI. It's a specification group similar to ITSI NFV. And after this webinar, you can just search on ITSI ZSM, and you will find these architectures and the specifications. And then I brought another example because I always stressed that orchestrator exists everywhere in all domains. You have just to understand the interlocks. So that's one of the MEF specifications doing architecture for SD-WAN, software-defined WAN, with a UCPE, universal CPE. I hope most of you are familiar with the term. So you see on the controller level, there is a SD-WAN controller that is manage the SD-WAN connectivity between branches. And you have the NFV resource orchestrator. And I like the way they use the term because actually it helped me explaining the concept. So they call it NFV resource orchestrator. So it is responsible on the VNFs on the resources level. So you see here on the CPE leased to the customer, there is a VNF, like a firewall, for example, or any kind of VASs, value added service. So it is being orchestrated as a lifecycle management from the NFV resource orchestrator. So both of them are in same level. So that's the resources layer. And then on top of that, there's a service orchestrator. So again, that's an architecture from the MEF showing the different orchestrators integrating with each other. And then we have the open source MANO. The open source MANO is some sort of the application of the ITSI NFV stack in a deployable format, and they are really doing a great job. What I want you to detect here, for example, OSM data models, that's the way you do the modeling. So that's a design time. The DevOps tools, again, that's part of the design time environment. In the runtime environment, and if you remember, I told you that OSM, open source MANO, spans across multiple domains. So it spans across the resources and service domain. So you have the resource orchestrator, and also you have a service orchestrator engine. So it's a way from open source MANO to give you a workable solution that does both resource orchestration and service orchestration. And we have the ONAP, okay, the Open Network Automation Platform, originally coming from Red Hat, from AT&T eComp, and collaboration with OpenO. They both formed the ONAP. So the ONAP is an automation platform. If you see the ONAP, you see there's a design time environment, include all the service design and capabilities and tools. So it's very aligned to what I'm saying. And it had the runtime environment that include all the orchestration logic. I'll just pick some blocks. This inventory, active inventory, service orchestration. So they are doing both resource and service orchestration, policy framework, including the policies, closed loop automation, very similar to what I'm saying. And this kind of application control and the VFC, these are like what maps to the NFVO in the ITSI NFV. So ONAP is a bigger, I would say, frame than the ITSI NFV. I got one question in the chat about open source MANO and ONAP. Both systems are there. Both are thought to be open source. It's up to the CSP if he wants to go through the journey to have their own development efforts, deploy open source solution. But unfortunately, this is not the case. The majority, I would say, not the big ones, but the majority will always go to a vendor solution to, for the accountability and to avoid any kind of risks. Orchestration, as I said, it can come from a use case perspective. So here, I'm bringing the network slice as a service framework. So a network slice as a service framework, or the 5G orchestration, was there in the 5G 3GPP releases in actually R15, R16. So what does it advise? For example, they are saying that there will be something called CSMF, NSMF, and that's communication service management function, network slice management function. What I want to tell you is that these new functions, they map to these kind of market solution. vendors position this CSMF and SMF into solutions called multi-domain orchestration, slicing manager, end-to-end service orchestration, or sometimes some vendors they abstract. Sorry, they were able to welcome this CSMF under the SOM, right? Some of the vendors are positioning the CSMF are part of the SOM. So any kind of order coming from the customer or from sales marketplace, it will go to CSMF and SMF as an orchestration. It will do service decomposition to whatever domain the slice lies on. So as per 3GPP, as per the standards, as per our hopes, that slice will be decomposed into 3 sub-slices into the radio, transport, and the core. And each domain has its own domain orchestration. So there's a core domain orchestration, transport domain orchestration, access domain orchestration, or the RAN domain orchestration. And then once this request comes, there is a part where you start to talk to the cloud layer, okay, to instantiate this kind of slice or virtual slices. So there are 2 approaches, because there was also one question about the future of NFVO. So there is one track where the domain orchestration integrate with the NFVOs, and the NFVOs integrate with Kubernetes-like solutions. And there's another approach to get the NFVO out of the game and integrate directly from domain orchestration to Kubernetes or the similar solution in the market. So this is architecture. I had to go a little bit fast because I have the same slides, but with flows. So flows will make the picture more clear for you. Let me just stop here and have one question. Sorry, have some questions and then come back. Okay, so is it mandatory to have Kubernetes or orchestrator as an orchestrator for CNFs, or it is possible to orchestrate CNFs with NFVO and the VNFM? In reality, the standardization effort to do orchestration for CNFs in HCNFV is very slow, and the market cannot tolerate that. So Kubernetes-like solutions would be there, but what we are working on now is actually a cooperation between Kubernetes or similar engines and the NFVO. The VNFM role is really fading with the existence of the Kubernetes. So the impact mainly on the VNFM, not on the NFVO. When it comes to telecom, then using MANO is feasible for orchestration. Yes, MANO is being used by many operators following HCNFV architecture. Guys, I have tens of questions, so I will just pick another one. Does design and runtime exist on the same node? Usually, design time environment of the orchestration, it is there in the staging environment. It is a staging environment, and the runtime exists on the live sites or on the live POC, and you establish a pipeline where you do the testing on the design, and then you push on the runtime. Okay, last question. Is orchestration system all about SDN and network slicing? No. There are a lot of other use cases, as I showed. Orchestration there in the RAN, orchestration there in the transport, orchestration there in many enterprise solutions, orchestration there in many consumer services like normal onboarding of packet core, of IMS, of whatever. So there are a lot of use cases for orchestration. I will answer all these questions offline. So let us just now see the flows. I think this will make the picture more clear. So guys, you're using the chat for the questions. I hope you can use the questions, because the questions, I will have it offline after the webinar. Okay, so let's have now some orchestration flows and see the role of the orchestrator in different domains. What does it do actually? So I picked 2 flows from HCNFV. One is the VNF instantiation, and one is the VNF scaling. Okay, so I will not go into the bits and bytes of each message, but I will go on to explain the theme of the flow. So you have the NFVO, you have the VNFM and the VIM, and that's the main bricks of the MANO, like NFVO, VNFM, and VIM. And you have the VNF that's going to be onboarded, and the EMS, that's the element management function, doing the FCAPS thing, like fault management, configuration management, accounting, performance, and security. So let's say the instantiation starts from the NFVO. Either it is triggered by northbound system or by an administrator. So the request goes to the VNFM from the NFVO, instantiate VNF request. So it's some sort of capability of the order management. So you put the order to the VNFM. Regardless what the VNFM is doing, that's very HCNFV internal, like related process. Like it creates something called VNF LCM operation occurrence, and then respond back to the API by accepted. And then it does something important. Step 6, you see that VNFM is sending a grant request to the NFVO. As if VNFM is asking NFVO, please, I want to instantiate the VNF, and these are the resources required, and these are the constraints, and these are the limitations, blah, blah, blah. So the first question, how did the VNFM knew the resources required and the constraint and the limitation? The answer is the VNFM has access to the VNF catalog, so it knows the modeling of the VNF and it knows the requirement of the VNF. That's number one. Number two, why it is asking the NFVO for granting? Because NFV orchestrator is doing resource orchestration. So he's the one who sees the resources end to end, and he sees the utilization. And maybe as a result of this request, he can tell the VNFM, no, do not instantiate because there are no enough resources. Or no, I have a policy that mandates that you as a VNFM do not do that. So it's always mandatory and recommended actually to consult the NFVO before doing any kind of lifecycle management, before doing instantiation, before doing scaling, before doing healing, because that's the brain of the NFV or Telco Cloud environment. So once the request is granted in step 7, in step 8, the VNFM communicate to the Vim. You can say it like OpenStack, for example, and communicate with OpenStack to bring up the VMs and the connection between the VMs. So again, the question, how did the VNFM knew that I need to instantiate this number of VMs, the VM flavors, the interlocks, all these are the VNF descriptor in the VNF catalog. And then once the VNFM does the resource allocation, and once the operation is finished, the VNFM notify the NFVO that the VNF is up. Why? Because NFVO will have to update the inventory that now we have a VNF record with this kind of resources utilized. So you see it's a mix of catalog, inventory, and closed loop control. And then once the VNF is up, you put the day 0 configuration, you communicate with the EMS to do the day 1 configuration. So that's an example of an instantiation. What will be more interesting will be the scaling. So in scaling, there are a lot of tens of triggers that can be used to trigger scaling. But I picked one of the standard approaches that VNFM is having some sort of relation with the VNF, asking the VNF to, it's some sort of a model of subscription. Like, for example, the VNFM subscribe to certain parameters on the VNF, okay? And these parameters either periodically sent from the VNF to VNFM, or whenever a threshold is crossed in the VNFM is notified. So that's the monitoring artifact that was defined in the VNF descriptor that I explained in one of the slides. This is part of the VNF template, VNF descriptor, that these artifact or these monitoring parameters will be monitored for the sake of lifecycle management. So let's say that this monitoring parameter is, for example, CPU utilization. So VNFM keeps getting information about the CPU utilization. And once the CPU utilization comes to a certain threshold, let's say 80%, VNFM take a decision to scale. So how did the VNFM made such decision? Because this policy is defined in the VNF descriptor that when the CPU reach 80%, you have to scale. So that's a closed loop control thing. We did the instantiation in the first slide. We kept monitoring. We detect a threshold being crossed. We do scaling. So that's a closed loop control, and that's part of the orchestration capability. And then VNFM in 6, as we know, it will ask a grant from the NFVO. Can I do this scaling or not? Are there resources or not? Do you have any issues or not? If yes, sorry, if no issues, then the grant response will be there, and VNFM will scale. Most probably it will do scale out, and because there was one discussion about scale out to scale up, like horizontal or vertical scaling, in NFV, in Telco Cloud, in VM world, in Telco, we do scale out. We add VMs. We don't do scale up, scale down. We do scale out, scale in. Okay. So before, well, let me just do that, and that's the logic of the 5G network slicing as a service call flow. It is informative because it is true, but for sure there are a lot of other parameters that I intended to hide because of the complexity. So the customer comes and put an order on a digital marketplace. Like, for example, I want a network slice. For example, slice bronze or slice gold. This request will come to the CSMF, the new product or a new solution from 3GPP that's absorbed by most of the orchestration solutions from the vendors in the service layer. It comes to CSMF, and as I said, I called it here slice MVNO. For example, the request will come an API. We need to order or provision a slice MVNO for this customer, and CFS means customer facing service. CSMF will translate this request, okay, based on the service descriptor of this service that they're in service catalog to NSMF. Then please, NSMF, you are the one interfacing with the resources domain. Go and fulfill this service. NSMF, with the decomposition capability of an orchestrator, it decomposes the service order from CSMF into three, either resources order or service order according to the logic, to the access, to the transport, and to the core. NSSMF, that's network slicing subnet management function. And as I showed on the slide, this maps to the domain orchestrator by many vendors in the radio and the core and transport. So NSMF will get the service order, and based on the template in their own catalog of the domain level, it knows that it needs to contact or decompose the service into different resources nodes in the resources domain. And here I take the example of the core for simplicity. So the NSMF from the core gets the service order from NSMF, and then it will translate this service profile, okay, to a request to the NFVO. The request of the NFVO will simply asking NFVO to instantiate a network service that may consist of, for example, UPF and SMF. That's the slice on the core. So this kind of request will go to the NFVO, and that's a standard API at the end. It's the NFV standard API. And then NFVO, if NFVO it is there in the path, or it is directly the Kubernetes, it will get the API, and then it will fulfill that. It will instantiate the slice on the cloud level, okay, either via NFVO or by Kubernetes or containers management. And then once the core is up, a new function gets triggered. By the way, here it's a little bit. I'm sorry. This one is NFMF. I'm sorry. This one should be NFMF, and that module NFMF is very similar to the EMS. It push configuration to the core slash subnet. So that's an orchestrated flow, okay? And the good thing that it uses multiple orchestration level. For example, it uses CSMF, NSMF. Some people or some colleagues put CSMF in the IT level, on the BSS level. NSMF can be there in service domain. NFVO Kubernetes can be in the resources domain. NSSMF can be on a domain level, so it maps between, it actually between the service and the resources, or maybe gathering both aspects. So that call flow requested the cooperation from multiple orchestrators from multiple levels. For sure, this architecture makes a lot of sense if you have a multi-vendor environment and really like clear borders between teams. But if you are a greenfield operator and you're using one vendor, most probably all these will be included somehow in a one vendor solution. Let me get some questions before we go to maybe to one of the final sections. Okay, how does healing happen when there is a degradation of 5G service? For example, quality of service ARP degraded due to congestion. I like this question, okay? And for that question, I will go back to the last slide. And guys, just please now focus with me. So the question is, you have a slice, a 5G slice, and then there is a need to do healing. For example, the service is misbehaving, okay? And you need to do a healing. How can you do that, okay? So that's a good question. Why? Because he said that healing resulted of a degradation on the service, like quality of service. Unfortunately, the cloud doesn't see this part, okay? So the easiest thing for cloud to trigger healing is actually to see misbehaving on the VM level, VM not responding, CPU utilization, misbehavior in a cloud part. But what is the case if the misbehavior is coming from the service layer? That's why, for example, something like the NSMF and the NSMF on the service level, and if you remember, the orchestration spans across multiple processes. So orchestration can include modules for FM, PM, and also it can include modules for service quality management, for SQM. So these kind of service orchestrators, they can detect any change on the quality of service or QoE, and based on that, it can trigger the cloud or the NFVO to trigger healing. So that's healing triggered from northbound systems. And personally, this is the kind of logic that I like. I like always that any kind of lifecycle management logic, like scaling, healing, should be triggered from systems that see the service. So it all comes from the orchestrators on the northbound layer on the service domain that include this kind of module that can detect the degradation of the service and trigger southbound systems like NFVO or Kubernetes to do the healing. I hope this answered the question. So what's happening in reality, right? Why the picture is not that bright, and why there is always conflicts and uncertainty, and I'm sure even you can see that in the poll results and even in the questions, why we all have different perspectives. Okay, so the challenging and for adoption for a full orchestrated framework to do agile service delivery and these kind of things, there are many things, but I chose 6 of them. One of the main challenges that we face in reality is actually we have always confrontation when we define the borders and the interlocks between different orchestration layers. And it goes really very harsh in the organization when they don't have enterprise architecture. So people fight on scopes, and it gets really dragged out of the technical discussions when you try to justify why there should be a service orchestrator on top of NFVO, why you should bring CSMF, NSMF while I do have OSS. At the end, there are a lot of gray areas, and decisions should be taken on a practical and approach should be taken based on references, should be taken based on a deep assessment, not just decisions taken, just this team takes that and this team pick that. So this kind of confrontation always is the main reason for not being able to have an end-to-end solution. Because as you see, for example, in the network splicing, there should be a cooperation from multiple departments on multiple orchestration level to deliver a service. So if there is no such harmony in the organization, then nothing will justify the investments done on the orchestrators, because you will not be able to deliver use case simply. Brownfield limitations, and that's something people working on the orchestration, they know that. Usually you come to deployments where they have some sort of silos or some sort of stacks, like silo stacks based on vendor X or vendor Y. So this kind of vendor lock prevents the company or CSP to have some sort of orchestration framework or to deliver use cases in an agile way, because each vendor has its own solution, and they try to push the vendors into a certain direction. Limitation in the products, limitation on the capabilities. So usually it is very hard to introduce an orchestration as a brownfield. So my humble advice is that if you have a possibility in a brownfield deployment to produce or to introduce an orchestrator, even without use case, please do, because after that it becomes very painful. Third thing, the market FUD. Okay, and FUD is actually the fear and uncertainty and doubt. And that's how the vendors, and I'm one of them for sure, that's how the vendors, they use such technique to enforce certain directions on their customers. FUD, like you go to the customer and you raise some fear, like what you are going to do if you are using open source MANO on app. This is an open source. Orchestration never happened. Multi-vendor never work. You have requests from the business you will not be able to fulfill. Uncertainty, you say that, okay, there are a lot of directions. Which one should you follow? We are not sure if this will work. HCNFV is dying. This kind of things. And doubt, that you just raise doubts. Okay, and ultimately the result of these three things, that customer, okay, will go to you and tell you, okay, give me an end-to-end solution. And once you do that, you put yourself in a dead vendor lock thing, and khalas. The fourth thing, the market fragmentation, and that's a reality. There are a lot of directions in the market. So if I am a CSP now, willing to go for a cloud native thing, will go for an orchestration, for network slice as a service, for network as a service, there are a lot of tracks, a lot of open source groups, a lot of communities, and we as a telco tribe, and again, I do have a telco background. We like references. We like to follow references and standard architectures. But if you have multiple approaches, that actually decrease, or that stops or even lower or slow the adoption of the technology. This happened in NFV, and it is happening in the orchestration. Fifth thing, the legacy procurement procedures. Think of that way. The way you used to procure a box, a router, 100%, it cannot be the same thing that you use to procure an orchestration solution, or for example, artificial intelligence solution, okay? Because the way you do RFPs or RFX by having tons of requirements on a SOC, and then asking vendors to say fully compliant or partially compliant or non-compliant, and then you do a price war at the end, that usually will bring you the same vendor that you have for the last years, because they knows and they know the process. But for the new technologies, it can't be like that. For the new technologies, I do encourage CSPs to change the procurement models and ask for pilots, ask for testing, that you guys come to my lab, I'll give you the infrastructure, we develop use cases, I do the testing based on certain KPIs, based on whatever, and who wins I would say who is technically fit and wins this kind of testing or phase, whatever, okay, should move now to the commercial, and we talk to it commercial. So the mentality or the process must change. The organization structure, the way most of the CSPs now are structured, like IT, network, transport, whatever, these are now somehow islands. And as you saw, most of the orchestration use cases spans across multiple domains and multiple processes. So this kind of organization structure are always, I would say, the obstacle, the main obstacle, because everyone looking forward to capture a scope, to capture a value. So there are a lot of confrontation between the organization. In order to have a scope in domain X to integrate with scope Y, you have to have a scope in domain Y to integrate with domain X. So the procurement cycles are not aligned because everyone is working on an island. So this kind of legacy organizational structure will never make the orchestration framework or end-to-end picture work. And that's why that's the benefit or the good thing about the new players like for example, Rakuten, it's a greenfield thing, like Dish. So they are building everything from scratch. Sorry, not from scratch, as a greenfield. So they have now the luxury to build the right organization that supports the technology. Let me take one question, and then I will have 5 minutes discussion. Okay, there is one question. Can we have an SSMF and NFVO in one product? Well, when you do products, so it's up to the vendor to combine whatever he wants in it, right? So some vendors, and I explained that some vendors have orchestrated solution that maps that spans across domains. So some vendors, sorry, they combine NFVO with NSMF. They combine NFVO with Edge Orchestrator. They even combine NFVO with Service Orchestrator. So it is up to the vendor on how he wants to enforce a certain thing. So yes, it can be in one product, and we have this example on the market. So I take the last question. So in telco domain, basically we have two types of orchestration. I'm reading the question. Service, end-to-end customer service orchestration at a higher level, and the resource orchestration more toward the network and system level. The latter is close to SDN and SDN controller. The former is close to the NFV and the MANO. Is understanding correct? Well, actually, there are multiple levels, okay? I would say that you have domains, multiple domains, and you have a multi-domain layer, and you have a resources layer. So most in practically, the case is as follows. You have an orchestration for the cloud that can be one or many, that can be NFVO, that can be Kubernetes, that can be both of them. So that's the resources. And then on each domain level, for example, core domain, transport domain, radio domain, whatever domain, X domain, you have an orchestrator for the domain. That's a domain orchestrator. On top of that, you have the multi-domain orchestration or the end-to-end service orchestration. These are the three levels of orchestration that I personally identified during my work, and it is very aligned to ZSM and to TMF. So I just took 4 questions from the meet and greet chat. I will respond to that quickly, and then I will see if there are any other questions. So the future of MANO layer. Well, when someone asks about the MANO layer, this means that there is a feeling that MANO is threatened. Okay, and I cannot acknowledge that, and also I cannot also deny that. So MANO is the NFVO, VNFM, and the Vim. And in HCNFV, the Vim was talking about only governing virtual machines. So we can map that to OpenStack. So Vim now is more into containerized workloads. So it became like something like Kubernetes or something like that. So HCNFV still not yet there in managing Kubernetes-like solutions. So Vim, yes, is threatened. VNFM, what Kubernetes is doing, taking care of lifecycle management of the CNFs, is very close to what VNFM is doing in standards, right? So yes, VNFM is completely threatened with the Kubernetes, but the vendors now is inventing something called CNFM, right? But at the end, Kubernetes can do that, okay? Or the map solution to Kubernetes, like OpenShift or OpenIO, whatever. And then the NFVO. So does Kubernetes possess threat on the NFVO? Well, NFVO can still be there because you can still have hybrid service that run across Kubernetes and, for example, OpenStack. NFVO can govern multiple clusters. So there are still space and use cases for NFVO to be there integrating with Kubernetes. So NFVO is still there. But yes, there are people in community believe that the MANO is in danger, or even the NFVO is in risk. ONAP and HC MANO, what is the most adopted by the industry, vendors, and the operators? Well, most probably, if you don't have an army of developers, if you don't have developers, then most of the operators start with an HC MANO approach to deploy their telco cloud based on HC MANO. Some are using ONAP, especially the operators that are contributing to the ONAP. You'll always see AT&T, you'll always see Orange. So both exist. And for example, there was one, Telefonica in Chile, they had a recent post about building a T-Cloud based on HC MANO. So both are there. What is the strategy towards the network as a service in service providers? So I will just stop here. So network as a service maps to what I've explained to the concept of domain orchestration in a more or less. For example, you are transferring all your domains into domain that can expose service. So you have a core, IMS, radio, whatever. So all these domains with the NAS can expose service together with other domains like SD-WAN, transport, and whatever. And all these services can be consumed by a multi-domain orchestration that can, at the end, translate these capabilities into a product or a customer product, something like that. So the NAS, all people are going to the NAS because they are all looking for new revenue streams coming from enterprise services. They want to transform all their domains into a service exposing domains so that they can get value out of these domains. And we will see telecom service application as cloud native application or hybrid models. Definitely we will go for hybrid models because the rate of momentum of migrating the VNFs, telco VNFs into cloud native will take a long time, because there are some network functions that don't see the necessity of becoming cloud native because they are very static and stable and there is no lifecycle management. So they live on virtual machines and they are happy. They can live on bare metal and they are happy. And we don't see a need to transfer that into cloud native. But the new wave of applications like the 5G, for example, 5G core and the O-RAN, are all going to that cloud native arena, right? And we will see orchestrator will become beneficial in hybrid deployments. Yes, exactly. The hybrid thing is a key word. Now orchestrators on the market are all competing to show themselves as a hybrid or a multi-cloud or a multi-domain orchestrator. So an orchestrator that can integrate with OpenStack, with Kubernetes, with AWS, with Google, with Azure, right, with VMware, that should be the perfect orchestrator, and all of them are evolving. Is there any reference architecture for orchestration and automation with workflow? Actually, this is a very good question. So orchestration, as I said, is a generic term, and I showed the example that there is a reference architecture for SD-WAN orchestration, reference architecture for HCNFV, which is somehow telco orchestration, and you have the OSM, you have the ONAP. So according to the use case, according to the domain, you will find these references, and I will try maybe offline to bring the exact references of whatever I showed in the slides. I will send you the links of these slides. That's all from my side. I'm really sorry I took almost 2 hours, but it's an interesting topic, at least for me. I hope it was interesting for you. I will group all the questions, I promise, and I will answer that. And I'm happy if you have any questions, maybe one-to-one, you can send it to me.